We're going to solve 10 raised to the negative x power equals 4, and we're going to estimate our solution to 4 decimal places. Now, in note 122, we saw a method which I'll call method A, and we're going to use that method to do this problem, but I'm also, for contrast, going to use another method B, and then you'll be at liberty to use whichever method you prefer. So for method A, using note 122, let's jump to the first step, which says isolate the exponential. Well, that's already done. 10 to the negative x is already alone on the left side, and it's equal to the number 4. So we can move to step 2 of method A, and it says to translate. So we're going to translate this exponential form to the log form using the butterfly wing. Log base 10 of the number 4 is equal to the exponent negative x. Now get negative x on the left side. And now, step 3, we solve for x. And we're almost there now. All we need to do is divide both sides by negative 1, and we'll get x equals negative parenthesis log base 10 of the number 4. Now, you're saying, well, what about that negative sign? Shouldn't you bring that negative sign as an exponent, a negative 1 exponent for the number 4, and then write 4 to the negative 1, which is the same as 1 over 4? Well, sure, you could, but I wouldn't see any reason to do that. I went ahead and solved it because the only thing I need to do now is run it through my calculator, which I'll do in just a moment. But if I were taking an exam, I could stop right here and be perfectly happy. Now let's look at method B before we simplify that any further. Method B says, well, step 1 is the same as method A. We isolate the exponential on the left side. So doing that, well, we don't have to do it because it's already done. We already have 10 to the x, negative x equals 4. So now step 2 is what's different. Instead of translating, this is base 10, we're going to take log or natural log of both sides. Well, in this case, we're going to do log base 10 because our exponential is base 10, and we want to cancel out the log and the base 10 since they're inverse operations. So you can only use this method if you're dealing with a base 10 or a base E, because you want to be able to, well, actually, no, you could actually do with any base. You would just have to take the log of the base using the base of the exponential, but then you'll have trouble running it through your calculator. So I only use this method when I have a base 10 or a base E exponential that I'm trying to solve. So I'm going to cancel by taking log base 10 of both sides of the equation. So it's log base 10 of the left side, 10 to the negative x, equals log base 10 of the right side, 4. And we see the log base 10 and then the number base 10 cancel each other because they are inverse operations, and it leaves negative x. Bring down the equal sign, bring down log base 10 of 4, and then step 3, solve. Just divide both sides by negative 1. We'll get x equals negative parenthesis log base 10 of the number 4. So we got the same answer. Now it's time to say, hey, if we were doing this as homework, we'd have to run it through our calculator. So let's see if we can get the calculator to work. The conclusion is use your calculator and evaluate negative log base 10 of the number 4. And we're going to get a decimal that's going to round to 4 decimal places. I didn't show you where it rounded. Well, I actually wrote it in here. You see on the right, lower right, it shows where I actually did the calculation and came out with negative 0.60205999913. And I want to round it to 4 decimal places, so I went out to the 5th place after the decimal point, and I found that was the number 5, which means I'm rounding up. Remember, you round up for 5, 6, 7, 8, or 9, which means I'm dropping the end of it 599913, but I'm adding 1 to the position immediately on the left side of the arrow. So this becomes 0.6021 when I round up.